We have several theorems in this section, so I just want to summarize a few. I did want you to make sure that you know that, for instance, in this first diagram, angle NPM equals 90 degrees. Well, the arc that is associated with that, isn't that also a fourth of the circle? So we would say that the measure of arc MN is also 90 degrees. So the central angle is going to be the same as its arc. So for instance here, if I needed to know the angle measure here, it would be 67 degrees because it's going to be the same as minor arc LM. Now I could also figure out the measure of angle KPL. And how I could do that is I know that since KMN, arc KMN is a semicircle because it's running through the center, I know that those three have to add up to 180. So I could do, if you wanted to do it algebraically, x plus 67 plus 90 has to equal 180. And so we would just simplify this to x plus 157, and then I would subtract. And so x is going to be 23 degrees, if I let that be x. So which that also means that the measure of arc KL is 23 degrees. So you have to recognize that your central angle is going to be the same as that arc that is associated with it. Now, the other thing I want to talk about is, for instance, don't forget what you know about vertical angles. So, for instance, since the measure of angle KPL is 23 degrees, this also has to be 23 degrees, which means you could find this measurement because here, once again, we have a semicircle. And so let's just say you had to find the measure of arc KO. Well, you could do 180 minus 23 to give you 157 degrees. Okay, now we have some theorems, several theorems that are talking about your central angles with the measures of the arcs, but also some chords. So one of your theorems that we have says that congruent central angles, so like in example 2, notice we have two congruent central angles because they're vertical. So they're marked that they're congruent. They also, the theorem says, if they have congruent central angles, they're going to have congruent chords. So that we could say line segment BE or chord BE is going to be congruent to CD. So that's one theorem. Another theorem says if you have congruent chords, you must have congruent arcs. So if you happen to know that those chords are congruent, then you also know that, let's say, arc BE is congruent to arc CD. And remember, we could also write it, the measure of BE is equal to the measure of CD. But the theorem actually talks about how the arcs are congruent. It doesn't really specify the measures, but we just know that because we have congruent arcs, the measures are going to be equal. And then it also says, okay, well, what if you know that you have congruent arcs? then you have to have congruent central angles. So right here, where these central angles were marked congruent, if you know any of those pieces, if you know that the central angle is congruent, you know the arcs are congruent, or the chords are congruent, or let's say you know the chords are congruent, then you know the central angles are congruent. Let's look at a couple more, and we may not solve these all the way, but notice here you can see that these arcs are congruent. Well, that tells us that these chords, so WV has to be equal to YX. And so then you could plug in your 9x minus 34 equals 4x plus 1. And then another theorem that we have in this section talks about your perpendicular bisectors. So if you have a radius, like in example 4, right here you have a radius. And notice that that radius is perpendicular to a chord. So anytime that happens, then it is bisecting the chord. So when you have a radius that is perpendicular to a chord, it actually bisects that chord. So for instance, if you were trying to find, let's say, VW, you could actually use your Pythagorean triple, 5, 12, 13. And if you didn't know that, of course, you could use Pythagorean theorem. But because of our theorem in section 11.2, we now know that VW would have to equal 24 units. And there is one last postulate that I want to make sure that you know. You have done this for a long time with angle addition postulate, but we also have what we call the arc addition postulate. And we really used it when we did example 1 together. But I just want to show you how we read that. So let's take Vx right here. So if we have the measure of arc Vx plus, I'm going to take the measure of arc, it looks like it could be bigger than 180, so I'm going to write it as XYW. If we have the first arc plus the second arc, it has to equal the measure of V, and we could call this VXW, or you could have called it VYW, but that's your arc addition postulate. So the first piece plus the second piece equals both of those pieces together.